Hello students, welcome to lecture 15 of our online chemistry classes. We have completed the stoichiometry and stoichiometric calculations in the last class, and today we are moving to last part of this some basic concepts of chemistry, namely the stoichiometric calculations in solution. Stoichiometric calculations in solutions, also called as mole concept in solutions, also called as concentration terms of solution. So we are dealing with this mole concept, how we can apply it to the solutions, or the stoichiometric calculations, how we can do that in the solutions, or what are the different concentration terms in solution. This is the thing which we are learning now. Before learning this, we should know what we mean by a solution. We can define this solution, also called as true solution. Solution also called as true solution, because there are another type of solution, we call it as colloidal solution. To distinguish between these two solutions, the word true is added for solution, so it can be called as just solution or the true solution. We can define this as homogeneous mixture. Homogeneous mixture. Homogeneous mixture means the composition is same throughout and it appears only in one phase. Homogeneous mixture of two or more substances is called as solution or true solution. If there are two components, two substances or two components, that solution is called as binary solution. Binary solution. Bi means two. So binary solution is solution which contains two components. And in this binary solution, the component present in large amount is called as solvent, and the component present in small amount is called as solute. So binary solution has two components, solute and solvent. Solvent is present in large amount and solute is present in small amount. For example, when we say 2 gram or 20 gram sugar dissolved in 80 gram water, so this comparing this 20 and 80, and we found that this 20 gram sugar is a solute and this is solvent, like that. So component present in small amount is called as solute, and component present in large amount is called as solvent. Of course, this 20 gram we can convert into mole. 20 by sucrose is 342, and this 80 by molecular mass of water is 18, and we can compare it. In any way, the sugar component is less, that's why sugar is solute and water is solvent here. Now we have different terms to express their concentration. Why concentration is important? Because what is concentration? Concentration is nothing but amount of solute present in the solution, right? So that amount can be expressed in various ways. That's why we have different concentration methods. But this concentration is important because utility of solution depends on concentration. Utility means use. How we use solution, that depends on the concentration, isn't it? If the solution is dilute, it can be used as antiseptic, it can be applied to living cells. If concentration is higher, it can be used as disinfectant, used to clean the floors, non-living things. Right, so concentration decides the use of particular solution. So concentration is very important. And as solutions are present in different way, we have different ways of concentration of solution. Few methods of concentration of solution are included in this topic. Few more we have to learn next year in PUC second year in solution topic. Now what are included? Some 4-5 methods are included. The first one is called as mass percent. Mass percent. Mass percent of what? Mass percent of solute. So how to calculate mass percent? We can say mass percent is equal to mass of solute divided by mass of solution multiplied by, as it is percent, multiplied by 100. So it is a mass of solute present in 100 gram of solution. That is called as the mass percent. If we use this example, 20 gram of sugar, 80 gram of water, this is solute, this is solvent. Together they make 100 gram of solution. Now what is the percentage, mass percentage of sugar? Mass of solute, which is sugar, is 20 divided by mass of solution is 100 multiplied by 100. 100 cancel, and we can say mass percent of sugar is 20. We will solve questions on it, but just try to understand the definition. Mass percent of solute is equal to mass of solute divided by mass of solution multiplied by 100. One more similar method, we call it as parts per million. In short form, it is written as ppm, parts per million. We can say ppm is equal to, see the similarity in formula, mass of solute divided by mass of solution. This ratio remains same, but as it was percent, it was 100, and as it is million, it is 10⁻⁶. So the formula is somewhat similar, but of course there is difference. Percent means out of 100, and parts per million means out of 1 million. So when we solve questions, again we will look into formula in detail. But now you try to understand what this concentration terms means. Mass percent means mass of solute in 100 gram of solution, and parts per million means mass of solute present in million gram of solution. So this is the two terms to start with. Formulas are very important because we use them frequently in the calculations. The third concentration term, we call it as mole fraction. Fraction means a part, and mole means it deals with number of moles in a solution. So see what this concentration term means. So this is third concentration term, which is called as mole fraction. We have solute and we have solvent, and together they make solution, right? See this table carefully. For mass of solvent, we use this term W. As solvent is more in proportion, we write 1 as a subscript. Remember, 1 substitute for solvent. Solute, as it is small in amount, we can write W2. And what is the mass of solution? It is mass of solvent and mass of solute, right? We can say similarly molar mass, capital M 1 because of solvent, capital M 2 because of solute, and there is for solution, as it is a mixture, only compounds have molar mass, so we cannot just add this and we cannot have the molecular mass of solution. Then we can say number of moles, we can write it as small n, and it is solvent, so 1. Small n, it is n2, and total number of moles of solution is n1 plus n2. We are talking only about binary solution because these are the only type of solutions which are included in our steps. Number of molecules, we can say capital N, this is 1, capital N, this is 2. So you can say that N1 equals to either W1 by M1 or N1 equals to number of molecules by Avogadro, right? This is constant. There is no Na1 and Na2 because Na is the Avogadro number, which is constant, and this one stands for solvent. Similarly, N2 equals to W2 by M2, or we can say N2 by molar mass of the solute. Now we have mole fraction here. I write here mole fraction. Mole fraction. What is the mole fraction of solvent? Denoted by x1. It is a ratio. Ratio of what? Ratio of moles of component. Component is solvent here, to the moles of all the component in the solution. So N1 divided by N1 plus N2 is mole fraction of solvent. What will be the mole fraction of solute here? X2 is equal to number of moles of that component divided by number of moles of components, all components present in the solution. So this X1 equals to N1 by N1 plus N2. N1 is number of moles of solvent divided by number of moles of solvent plus number of moles of solute. X2 is mole fraction of solute equals to number of moles of solute divided by number of moles of solvent plus number of moles of solute. For the solution, it is just denoted as X. X1 plus X2, and that equals to 1. It means if X1 is equal to 0.3, X2 is equal to 1 minus 0.3 equals to 0.7. This is the way in which mole fraction are expressed. What is mole fraction? Ratio of number of moles of component to the number of moles of all the components present in the solution. That's how we define the x1 mole fraction of solvent, x2 mole fraction of solute, together x, and x1 plus x2 for binary solution. The sum is always equal to 1. If x1 is 0.3, x2 is 0.7, if x1 is 0.4, x2 is equal to 0.6, like that. So this is about the third concentration term. And how to get this N1? If mass are given, W1 by N1. If molecules are given, N1 by available. In any way we can get value of number of moles of solute or solvent. That will be given in the question, particular question. We'll see that how it is to be calculated. Now, fourth concentration term is the molarity. Very important term in case of concentration of solution, because that is the concentration term which we use frequently in calculation, in chemistry practicals also. So what is this molarity? Molarity. This is called, written as capital M. So it is number of moles of solute. Remember, number of moles of solute present in 1 cubic decimeter, also called as 1 liter of solution. So it is a number. Molarity is number. Number of what? Number of moles of solute. And where they are present? In 1 liter of the solution. For example, we have here 1 liter of water, which is solvent. Into that, we have added 40 gram of sodium hydroxide. We know that sodium hydroxide, atomic mass of sodium is 23, oxygen is 16 and hydrogen is 1. So this is 40. So 40 gram of sodium hydroxide is nothing but 1 mole of sodium hydroxide we are adding. When we add to this becomes solution. This is solute and this is solvent, and together they make solution. Now how many moles of solute are present? 1 mole of solute is present. In how much of solution? 1 liter of solution. So we can say this solution as 1 capital M means molar sodium hydroxide. If we add 80 gram of sodium hydroxide, this becomes 2 mole. Now we can say that this solution is more concentrated because it contains more amount of solute, and it is now 2 molar sodium hydroxide solution. If we add 20 gram of sodium hydroxide, it is half mole of sodium hydroxide still dissolving 1 liter, and we say that we have 1 by 2, that is 0.5 molar sodium hydroxide solution. Now how to calculate this? What is its formula? Formula is very simple. Molarity is equal to number of solute divided by volume of solution in liter. Right. This number of moles of solute is written as N, number of moles 2 for solute, and volume in liter. This number of moles of solute can be written as W2 by M2 divided by V, volume of solution in liter. But generally when solutions are made, they are made in milliliters. So you can write this as mass of solute divided by molar mass of solute. This volume in milliliter. And if we divide this by 1000, that becomes volume in liter, because milliliter divided by 1000 becomes liter. So you can simplify this term and we can write W2 by M2 multiplied by this 1000, will keep it in numerator, and divided by volume of solution in milliliter, like this. So this is the formula of the molarity. W2 by M2 into 1000 by volume of solution in milliliter. What is this W2? It is mass of solute. M2 is molar mass of solute. V is the volume in milliliter. That is the formula of molarity. We can write this formula alternatively for this W2 by M2. If number of moles are given, M2 is number of moles of solute. 1000 by volume of solution in milliliter. In this way also we can write, or we can write molarity is equal to, this number of moles can be written as number of molecules of the solute divided by Avogadro number. This 1000 divided by volume of solution in milliliter. These are the different ways to express this formula. What is the unit? See the unit here. This is W2 is nothing but gram. Molar mass is gram per mole. 1. And this is nothing but volume in liter. Right. So this gram cancel. And that's why unit is 1 divided by mole raised to minus 1 is mole. And 1 by liter is equal to mole per liter. Or this is also called as mole per cubic decimeter. Is the unit of molarity. Now, if we have one solution of molarity M1 and we want to convert that into M2, we can do that. The volume V1 has to be converted into V2. And M1 V1 is equal to M2 V2. This is called as before dilution, and this is called as after dilution. If molarity increases, volume decreases. Such a way that M1 V1 is equal to M2 V2. We can use this in questions so that we can understand this in better way. Another one, we have one solution of M1 V1, molarity 1, volume 1, and we mix that solution into M2 V2, another one solution. Its normality becomes MR, which is nothing but resultant molarity. Molarity is resultant molarity into V1 plus V2. So resultant molarity after mixing these two solutions is equal to M1V1 plus M2V2 divided by V1 plus V2. This is one more formula with relation to the molarity. Another one way we can express this molarity, if we have mass percent of solute given in question, density is given, we can use this formula. Molarity is equal to mass percent of solute multiplied by density multiplied by 10 divided by M2, like this. Now this molarity depends on temperature. Depends on temperature. Why? Because volume increases. Volume of solution increases as temperature increases. They are directly proportional. So you can say as temperature increases, see here, as temperature increases, volume increases, and volume and molarity are inversely proportional. So as temperature increases, we can say molarity decreases. So molarity is temperature dependent concentration term. As temperature increases, volume increases and molarity decreases. That's how the relation between molarity and the temperature. We are looking into different formulas. We make one list of formula when we learn all concentration term, and then it is easier for us. But try to understand meaning of term in every formula so that we can use it effectively. This is about the molarity. One more concentration term, last one, is the molality. So see the molality concentration term. Molality. And to distinguish this, we have to write this in a small m. Molarity is capital M and molality is small m. We can define this. It is the number of moles of solute present in 1 kilogram of solvent. 1 kilogram of solvent, mass of solvent. We'll take one example once again of sodium hydroxide. We'll take this beaker and we'll take 1000 milliliter of water, which is nothing but 1000 gram of water, because density of water is 1, which is mass by volume. So mass equals to volume. 1000 milliliter is equal to 1000 gram, which is nothing but 1 kilogram of water. So this solvent we have to, and to this we'll add 40 grams sodium hydroxide, which is 1 mole of sodium hydroxide, which is solute here. So 1 mole of solute present in 1 kilogram of solvent. We can say that this particular solution is nothing but 1 molar sodium hydroxide. You are understanding this? Because 1 mole of solute present in 1 kilogram of solvent. In molarity, 1 mole of solute present in 1 liter of solution. But here we are dissolving that solute into 1 kilogram of the solvent. Why we are doing that? Because this is temperature independent. Because mass will not change by changing temperature. This is one way, one advantage of expressing the concentration in the molarity. But we can go to the formula and see how we can write this formula. We can write this as small m, and that is number of moles of solute divided by W1, which is mass of solvent in kilogram. This N2 can be converted to W2 by M2 into this is in kilogram, and this can be converted into gram, but by dividing it by 1000. So we can write one more step. W2 by M2 equals to this 1000 divided by mass of solvent, but in the gram. In this way, W is mass of solute, molar mass of solute, nothing but number of moles. 1000 and W1 gram. W1 is nothing but mass of solvent. This can be again written as, this number of moles can be written as just like this: number of molecules of solute by Avogadro number 1000 by this W1 gram. So this is also one of the formulas of the molarity. What is the unit? Unit is mole per kilogram. How the unit is mole per kilogram? This is gram, this is gram per mole. Gram cancel. 1 by mole is nothing but mole raised to minus 1 by mole raised to minus 1 is nothing but mole, and this is kilogram. So it is per kilogram. Independent of temperature, does not depend on the temperature. And how this related to molarity? Molality, relation between molarity and molarity. Molality is equal to 1000 into molarity, 1000 into divided by 1000 into density minus molarity into molecular mass of the solute. This is molarity, this is density, again molarity, and M2 is nothing but molar mass of 2 means solute, right? One more relation we can have, relation between molarity and mole fraction. 1000 into X2 mole fraction of solute, X1 mole fraction of solvent, and M1 molar mass of solvent. This is the relation between mole fraction of solute and solvent and the molarity. So these are the 5 concentration terms we have: mass percent, parts per million, mole fraction, molarity, and and molarity. These are the way in which the concentration of solutions are expressed. We have many formulas with us. We'll make one list of formula so that we can use them effectively in the calculation part. So I will make that list. You also make the list of this formula because we can use them very efficiently if we know the meaning of them, and most importantly what it means, various terms we are dealing with and what that terms mean. So first one is mass percent of solute, and that is W2 divided by mass of solvent plus mass of solute, which is mass of solution, into 100. Next is parts per million. It is nothing but mass of solute, mass of solvent plus mass of solute, mass of solution, into 10 raised to 6. Next is x1 equals to n1 divided by n1 plus n2. x1 is mole fraction of solvent. x2 is equal to n2 divided by n1 plus n2, and x1 plus x2 equals to 1. Fourth is, after this mole fraction, we have molarity. W2 by M2 into 1000 by volume in milliliter, or that equals to number of moles of solute 1000 by volume in milliliter, or that equals to number of molecules of solute, Avogadro number, 1000 by volume of solution in milliliter. One more formula for molarity is molarity is equal to mass percent into density into 10 by molar mass of solute. Then we have dilution formula. M1V1 is equal to M2V2. Then we have molarity of solution M1V1 plus M2V2, resultant molarity plus V1 plus V2. Then molarity, mass of solute by molar mass of solute, 1000 by mass of solvent in gram. Number of moles of solute, 1000 mass of solvent in gram, or this number of molecules of solute by Avogadro number into 1000 by mass of solvent in gram. And yes, I think this is enough. Only these many formulas we have used up. See the meaning of every term into this solution, into this formula. Only thing is that this one capital M means we can call it as 1 molar solution, and 0.5 molar also written as M by 2, and this particular is called as semi-molar solution. Semi-molar, semi-half. and then 0.1 molar, or written as m by 10, because 1 by 10 is 0.1, is called as decimolar. Then 0.01 m by 100 is called as centimolar solution, and 0.001 molar, nothing but m by 1000, is called as millimolar solution. So apart from this formula, the relation between molarity and molarity, so these 7 formulas are there. I will take one here. Small m equals to 1000 into molarity, 1000 into density, molarity into molar mass, and 9th one, 1000 into x2, x1 into m1. So these are the various formulas we are dealing with. We should know what this 2 means. 2 means related to solute, 1 means related to solvent. W means mass, M means molar mass, N means number of molecules, right? Here D means density. So you clearly understand this. 1 stands for solvent, and 2 stands for solute. Why 1 stands for solvent? Because solvent is large amount, and 2 stands for solute because 2 is in small amount. In that way you can remember. In some cases solvent is written as A and solute is written in B. They will mention that. There is no need to confuse it. When we solve question, it is up to us how we use it. But we should mention what we mean by 1 and what we mean by 2 every time. Then only there is clarity in our solution of question. So this list of formula is with us. We know the definition of mass percent, parts per million, mole fraction, molarity. So we should solve some questions, simple questions based on it. So the first question is, a solution is prepared. Yes, we have enough time to solve some questions. See how many questions we can solve today. The question is, a solution is prepared. A solution is prepared. A solution is prepared by adding 2 grams of substance A to 18 grams of water. Calculate mass percent of solute. So you can write the formula. Mass percent of solute is equal to mass of solute divided by mass of solution into 100. Mass of solute is equal to mass of A here. A is solute, which is 2 gram, and mass of solution is nothing but mass of solute plus mass of solvent. Mass of solute is 2 gram. Water is solvent here because it is present in more amount. 18, 20 gram. Hence we can write mass percent of solute. Mass of solute is 2 gram. Mass of solution is 20 gram multiplied by 100. This is 5. And that's why we can say that it is. So very simple question it was. Solute is to be identified. That which is present in small amount is solute and large amount is solvent. And solution is mass of solution is mass of solute plus mass of solvent. See the next one. This is for molarity. Calculate molarity of sodium hydroxide. Calculate the molarity of sodium hydroxide in the solution prepared by dissolving 4 gram in enough water to form 250 milliliter of solution. This is the question for us. We'll see what are the terms they have given and what are the terms they have asked. So M, molarity, which is nothing but capital M, they have asked us to calculate 4 gram of sodium hydroxide is dissolved. So mass of solute is nothing but mass of sodium hydroxide, written as W2, is 4 gram. This is the volume of solution. Volume of solution, which is V, equals to 250 milliliter. Capital M equals to W2 by M2 into 1000 by V in milliliter. This term is given. 1000 is constant. V is given. M2 we have to calculate. M2 is nothing but molar mass of sodium hydroxide, which is nothing but 40 gram per mole. How 40 gram per mole? Sodium is 23, oxygen is 16, hydrogen is 1. Now we have all the terms known to us. We can substitute correctly and we can get the answer. So we will substitute in the next step. Capital M equals to 4 gram 14, 1250. This is 4. This is 10. 4 by 10. This 0.4 m, capital M we can write. Or 0.4 mole per cubic decimeter we can write. Or 0.4 mole per liter we can write. We can express this in these terms or just we write capital M. That is nothing but molar. So this is the way in which this question can be solved. We'll take one more because these are very simple questions. Once we understand formula, we can solve easily. So we'll take one and then I will give 2 questions as the homework, right? Because solving homework is your very favorite activity, isn't it? So I will give that 2 questions. 2.8 gram of sodium hydroxide, potassium hydroxide is dissolved in water to give 200 cubic centimeter, which is nothing but milliliter, of solution. Calculate molarity. So once again, very simple question before us. 2.8 gram of sodium hydroxide. Mass of solute W2 is 2.8 gram. Volume of solution V is 200 cubic centimeter. Molarity capital M question mark. Yes, this is the formula. W2 is known, V is known, 1000 is constant, M2 is not known. Molar mass of solute. Molar mass of potassium hydroxide. Potassium is 39. Oxygen is 16. Hydrogen is 1. And this is 56 gram per. So everything is known now. Only 4 terms are there. One of the simplest type of questions. 2.8, 56, 1000 by 200, 5. We can make it as 28, 10 raised to minus 1 by 5, 56. This decimal point I have shifted to right, so I have multiplied by 10 raised to minus 1. 28 by 2 is 56. 5 by 2 is 2.5 into 10 raised to minus 1. So 0.25 molar. Always remember the unit because unit carries marks. So this is third question which we have solved together. I will give you 2 questions as a homework, right? So you write this question. If you are not completed, just pause this video and complete it because I'm going to write this question number 4 here, which is going to be a homework. Right, question number 4. The density of 3 molar solution of NaCl is 1.25 gram per milliliter. Calculate the molarity of solution. We have a formula which relate molarity and molality. We can write molar mass of NaCl 23 plus 35.5 58.5 gram per mole. So this is one question as a homework in relation between molality and molarity. It's quite clear. We have written one formula to relate that, use that formula. This one is also going to be a homework. Calculate number of moles and amount in grams of sodium hydroxide in 250 cubic centimeter of 0.1 molar NaOH solution. And as I can see, you are very happy by these 2 questions. One more I will do. Yes, only 3 last. How much volume? Of 10 molar HCl should be diluted with water to prepare 2 liter of 5 molar HCl. We have to use the formula M1V1 is equal to M2V2 for the last question. The first question is formula is relation between molarity and molarity. Second question, number of moles can be calculated by molarity and volume. Capital M equals to N2, number of moles of solute, into 1000 by volume. Once number of moles are known, N2 equals to W2 by molar mass of sodium hydroxide. M1V1 is equal to M2V2. Compulsory you solve these 3 questions, let it be correct or wrong. I hope that you solve this question. Thank you for watching this video.